Hello good people, I would like to talk about the nomenclature of aromatics. The quintessential aromatic is benzene, this compound here. And a lot of other aromatics have the name benzene incorporated in their name. In other words, benzene is a bit of a parent name for a lot of aromatic compounds. So let's meet a few. Let's bring in another aromatic ring. I will place it here. And I'm going to add a substituent, a single substituent. Let's say we add a chloro group. This compound now becomes chlorobenzene. Let's do another one. So here's the benzene ring again. And I'm going to add a single substituent. Let's make it a nitro group. So this compound now is nitrobenzene. Note that there is no need to number the carbons when we have a single substituent group, because the assumption is that the carbon that carries the substituent group automatically gets number 1. So yes, we could call this 1 nitrobenzene and we could call this 1 chlorobenzene, but the 1 is not necessary. The numbering, however, starts to play a role once we have 2 or more substituents. So let's look at a few of those. Here is the ring again. This time I will add 2 substituents. 1, and let's make another one here. I will make both of the substituents chloro groups. And now we need to number the carbons. As always, we aim for the lowest set of numbers. That means that one of these carbons has to be carbon number 1. And then we number in the direction that will give us the lowest set of numbers. So I could go 1, 2, 3, 4, 5, 6. In that case, the chloro groups are on carbons number 1 and 5. Or I could number it this way. 1, 2, 3, 4, 5. Pardon me, I just realized I cannot count. So it's 1, 2, 3, 4, 5, 6. There we go. In this case, the chloro groups are on carbons number 1 and 3. So we aim for the lowest set of numbers. That means that this compound would be 1, 3, indicating the location of the chloro groups. And then we need to say di for 2, because there are 2 chloro groups. And then we write the rest of the name out. Dichlorobenzene. All right, let's make it more complicated. So here's the aromatic ring. And this time, I will add 2 different substituents. So we will have chloro, but we will also have bromo. So we need to decide which one of these gets priority. So which one gets carbon number 1? Will it be 1, 2, 3? So we'll have 1 chloro, 3 bromo. Or will it be 1 bromo, 3 chloro? Well, the alphabetic order is important. So bromo comes before chloro because B comes before C. So in this case, the compound would be 1 bromo, 3 chlorobenzene. All right, let's do another one. Here's the aromatic ring. And we can have a substituent here and a substituent here. So we'll make this nitro, and we will make this bromo. Once again, we need to number the carbons. We can start up here and say 1, 2, 3, 4. Or we could start down here and say 1, 2, 3, 4. Which one is correct? Again, we need to look at the alphabetical order. So bromo before nitro, B before N. Therefore, in this case, we will have 1 bromo for nitro benzene. Instead of using numbers, we can also use letters to designate the relationship between two substituents. What do I mean by that? Well, let's bring the aromatic ring. So here's the aromatic ring, and I'm going to put in one substituent first. So, and let's make it bromo. With respect to bromo, I'll do a different color. This position here is known as the ortho position, shortened O. This position is known as the meta position, shortened M. And this position here is known as the para position, shortened with a P. So that if we have something like this, and let me just quickly draw it. Bromo, and I shall put a chloro group down here. We can say that bromo is para with respect to chloro, or the other way around. Chloro group is para with respect to bromo. So the name of this compound could also be P dash bromo chloro benzene. Once again, the letter P indicates that the bromo and chloro group are para to each other or counter to each other or on the opposite sides. Let's do another one. So once again, we will have two substituents. Something like this. And we'll make this one nitro, and we'll make this one chloro. So now, these two substituent groups are meta with respect to each other. So we will say that this compound is M chloro nitro benzene. Let's do one more. So here we have it again. And once again, we need two substituents. And please note that this naming, the naming convention where we use the letters OMP, ortho, meta, and para, works only if we have two substituents. So we can have chloro and chloro this time. Oops, there we go. So this time these substituent groups are, these two substituent groups are ortho to each other. They are next to each other. Ortho comes from Greek, which means straight. So you could kind of say it's ortho means straight next to each other. Meta means beyond, so beyond the next one. And para means counter to, so on the opposite side. So in this case, we have, what was I doing? That's right, I was naming this compound. So we have ortho, or O, and we still need to say dichlorobenzene. So the name is telling us that we have a benzene ring, that is the benzene part. It's telling us that we have two chloro substituent groups, and it's telling us that those two chloro substituent groups are ortho to each other, next to each other. Another name for this compound would have been 1,2-dichlorobenzene. benzene. So the use of letters works only when we have two substituents, and when we use the letters, we do not necessarily need to use the numbers. And that is all for now, and I will see you on the flip side.